Hello fellow problem solvers, so they're going to be doing a problem from the 2003 IMO shortlist problem number G3. I suggest you try this Nash problem out for a minimum of 15 minutes, ideally 30 to 45, maybe an hour, not more than 2 hours. If you'd like to go along with us, give it a go for the next 15 minutes. And now without further ado, let's begin. So, we have this triangle, okay, regular triangle, point P, that satisfies this if you add its perpendiculars. Ooh! And we have proved it's the circumcenter of the triangle formed by the excenters. Okay, so this means that this condition uniquely defines P, right? There's only one circumcenter of the excenters of the triangle formed by the excenters. So let's see. We have this, boom, triangle ABC. I'll just add the excenters straight away. Say 90. So then I have angle bisector, a 90-degree angle. I'll call this IC. I see you, you see me. And boom, 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 boom. And here we have IB and IA. Okay. And P should be a point like here-ish. Boom, here's where P should be. And now let's see actually, so we have this condition once we put the feet of the perpendiculars. So let me now delete this. Like, there are a bunch of things to note here. So one sort of perspective shift is what is ABC for the triangle IAIBIC? And the answer is like these are the feet of perpendiculars because IAA is perpendicular to this, so these are the feet of perpendiculars. So if we look at P is the same as in a regular triangle, in a triangle ABC. We have O, the circumcenter, and we have these perpendiculars. And what this is really saying is, if I put down a foot of perpendicular here, the distance between O and this is going to, distance between O, this squared plus this squared is going to be constant with regards to all the, actually no, this, I saw that something like this squared plus this squared is going to be constant among different ones I put, like the different feet of perpendiculars. And maybe this is easier to look at, just to see like, what do we know here about this thing? So maybe let's look at this triangle XYZ. And now let's see, I need this squared plus the distance from O to this. What is the distance from O to, the distance from O to this I know. So I have, and how do I get this squared? Well, maybe I don't get that squared, maybe I have a minus. So maybe instead of, let me actually put the two feet of perpendicular, say from P to AB and BC. So from P to AB, that's the point F, and here's the point D. So maybe instead of AP squared plus PD squared, instead of writing this as equal to CP squared plus PF squared, maybe I write it in terms of, what do I have? AF. So I have AF squared is equal to AP squared minus PF squared. And then by this, AP squared minus PF squared is equal to CP squared minus DP squared. And then CP squared minus DP squared is equal to CD squared. So I have this is equal to this. And here's where I might you to pause for another 10 minutes and see if you can push the problem further. And here's the next step. So this condition gives me that this is equal to this. AF is the same as CD. So I should also get that, analogously, if this point is E, I'll have, say, BP squared minus PD squared is equal to AP squared minus PE squared. And that means that AE is equal to BD. So I have this right here is equal to this right here. And also I should get that once I combine these two, then I'll get this is the same as this. Now, what does this mean for, so what are then these points D, E, F? I invite you to pause for another 5-10 minutes, figure that out. And the answer is, well, let's see. So let's call this length X, X, and Y, Y, Z, Z. What do I have? I have X plus Y is equal to, this is just sometimes like easier, is equal to C. I have X plus Z is equal to what? A. And I have Y plus Z is equal to B. How do I isolate X? Well, this plus this minus this, I isolate X. I get X is equal to C plus A minus B over 2. And that's why I have, or X is equal to S minus B. So it means this is S minus B. And then we get this thing right here is S minus C, S minus A, and S minus B as well. And what does this give us? I invite you here to pause for another 2 to 3 minutes and see, like, what does this in fact give us? S minus B, actually no, this is S minus B, S minus C, and finally Y, S minus A. So this gives us really that these points, F, E, like this is a point where the X center touches the line AB. So we have ICF is also perpendicular to this. And similarly, IBE is perpendicular, and so for point P, we have that PIA is perpendicular to BC. Like we get all these points are perpendicular, right? Now, what are the angles that we would have on the circumcircle, on the circumcenter here? Well, we'd have this angle would need to be 90 minus this angle right here, right? What is this angle right here? Well, because this is alpha, beta, this angle is alpha half plus gamma half. This is, what's it called? Beta half plus gamma half, plus gamma half. And that makes this angle alpha half plus beta half. So we need to show that this angle right here is gamma. However, if this angle right here is equal to, this is gamma, and because this is an angle bisector, external angle bisector, this is equal to beta half plus alpha half. Well, we could have actually solved this the opposite way. This is gamma half. Now, we could have also, I just saw this now, we could also have solved this by asking ourselves the question, like, you know, in geometry, as I mentioned before in this channel, you can solve the problem forwards. What does this mean? To, okay, let me get to the solution. Or you can go backwards and say, what will I have happen? What will happen, right? If P is this thing, then I know this angle will be gamma half. And then I'll have this angle right here. Because of this angle right here, I'll have that IBP is perpendicular to AC. But because E is what it is, I'll need to have, what's it called? I'll need to have E is the point where the X circle touches AC, and then from there, the problem follows. And then you know what you need to look for. You need to prove that this is equal to this from the condition. And then how do you do that? Well, you just switch these around. And I think, you know, it's a cool problem, you know, shows you a little bit of a, like, those are like the two approaches. Like I think what it shows you here is like you can go forwards, but also the most important part of the problem when you have something new is like actually notice what is new to me here. And the new thing is the thing that you need to figure out, right? You need to figure out how do I combine this? Like that is where the crux of the problem sometimes lies. Like once we figured out this, the problem after that sort of like just like naturally fell. And that's how we solved it. So this finishes up our problem, and as always, thanks for problem solving.